Good morning, everyone. Good to see everyone. Hope you had a good summer and you're ready to hit the ground kind of running as you were kind of forced to do yesterday. It looked like most of you handled the labs well yesterday, which is good. I remember this isn't your first day, but my first day of college was kind of similar in that I had a chemistry lab before the first day of lecture. And I actually had never had a chemistry class in high school. And that proved to be a problem that first day in college because I had no idea what all the names for the different things were. So by the end of that lab, I was pretty discouraged. Probably would not be as good to have those first labs if you were freshmen, but most of you are sophomores, so I figured it would be okay. So at any rate, my name is Brad van der Zanden, and that last name is quite a mouthful. It means from the sand. It's Dutch. You should feel free to call me Brad. Dr. van der Zanden is fine. Dr. Brad's fine. It's all good. This is CS140, Data Structures and Algorithms 1. And next semester, all going well in this course, you will end up taking CS302, which is Data Structures and Algorithms 2. So you've already had CS102, which is an introduction to programming. And most of you have had CS130, which is essentially an introduction to hardware. So CS102 was an introduction to software. CS130 is an introduction to hardware. CS140 and CS302 are about how you organize information or data to make it easy to manipulate. So in CS102, you were just interested primarily in learning the control structures for programming, things like if-then-else statements, assignment statements, loops. And then in the second half of the course, you started looking at some simple ways to organize information via vectors and classes. And we'll be reviewing that material in the first month of this course, so if those concepts seem a little shaky to you right now, don't worry about it. In this course, what we are primarily interested in is organizing data so that the following three operations can be performed efficiently. So we'd like to be able to insert new data into our so-called data structure. So a data structure, actually, a good place to start is what is a data structure, since that is the name of, part of the name of the course. A data structure is I'll say a structure for organizing data and manipulating it. So a structure for organizing and manipulating data. And we are primarily interested in three operations: insert, find, and delete. So we want to, in this course, find data structures that organize information in ways that make it efficient to find that information, in ways that make it easy to insert new information, in ways that make it easy to delete information. So a simple example might be a grocery list. In a grocery list, you want to obviously be able to easily add items to the grocery list. As you're going through the grocery store, you want to be able to easily find items in that grocery list, and presumably as you put items into your cart, presumably you'll cross off or delete items from that grocery list. If you're Google, obviously your big mission there is to allow people to easily find information on the internet? Well, before they find information, as Google, you have to find ways to add information. And obviously, you want to keep up to date. So as Google, you want to keep scanning the internet and adding new information. And also sometimes as Google, you are required to delete information, such as when the European Union passes privacy laws that allow people to opt out or to delete information, then Google had an obligation to delete some information from its search engine. So these three operations are pretty fundamental operations in computer science. They drive a lot of the business models of tech companies, or actually not just tech companies, but just about any company that is out there. And in addition to these three fundamental operations, which are going to consume the major part of our class, the other important thing is that these data structures can dynamically grow and shrink. So that should be pretty clear from the delete part, but the data can dynamically grow and shrink. So just cast your minds back to CS102 for a moment. Do you remember toward the end of the class being taught an algorithm called binary search, where you had an array or vector and you made the data, you had to sort the data. So you might have 20, 40, 50, 60, 80. And the first thing that you would do, if you were looking for some item in that vector, the first thing you would do is look at the middle item. And 40 was less than 50, so you eliminated the top half of the array. You looked at the bottom half. Does that ring a bell? Okay. So that was a way of organizing data. This was a vector. The data was sorted. It was an efficient algorithm for finding the information in the vector. But the issue with this algorithm was that the data was fixed. It was not easy to insert new data into the vector. It was not easy to delete data from this vector. It wasn't efficient. Okay? It actually is not that particularly hard to write code to insert or delete data from this vector, but it's not particularly efficient to do so. So that was a algorithm that worked really well with a fixed size data. For example, a telephone book, where you physically have the book, is a fixed set of data. Okay, of course, most of you have probably never seen a telephone book, so that tells you what's happened to them. They're now online directories that are dynamically added to or deleted from. So this course, as I said in particular, is interested in introducing you to different types of data structures which have different advantages and disadvantages in terms of these insert, find, and delete operations. So some of them are going to provide more functionality than others. Some of them will be faster, some of them will be slower, so we'll be looking at the trade-offs amongst them in this class. Also, hopefully in CS102 you were introduced to that term, algorithms, but in case you weren't, an algorithm is simply I'll call it a recipe, or actually I'll call it a recipe for solving a problem. And then your job is to translate that recipe into a computer program. So the data structure in this course is kind of the way of organizing information. Like in CS102, you used vectors as one way of organizing your information, and then the algorithms are the algorithms for insert, find, and delete. So binary search was an algorithm that operated on the vector data structure. So that's kind of the theme of this course. When you move on to 302, you'll still be looking at some data structures that are concerned with insert, find, and delete, but the emphasis in CS302 tends to shift more toward algorithms. So things like sorting, which is not something we're going to consider a great deal in this course, but that's an important operation also in computer science. That's something you look at more comprehensively in CS302. Different ways of constructing algorithms, and I'm not going to worry about that. But at any rate, the focus in this course is more on the data structures. The focus in 302 is a bit more on algorithms. So actually, there's 4 goals of this course, and this is just one of those 4 goals. And all 4 of those goals are, in my opinion, equally important. So I'll, in a moment, get to the logistics of the course, because I know many of you want to know about the logistics of the course, but I just wanted to give you an overview first. So there's 4 goals of the course, and here's the one I just talked about, to understand basic data structures. We also want you to start becoming more self-sufficient C++ programmers. So CS102 started you on that journey, and this course continues you on that journey. So there are a few differences between this course and 102. A big one in regard to becoming more self-sufficient C++ programmers is, instead of using what is called an integrated development environment, or IDE, so in 102 you use Code Light, or many of you use Code Light. In this course, we're wanting you to use what are called command line tools. Okay? So yesterday in lab, you were introduced to this notion of command line tools. Okay, so you were forced to use what we call terminal window, and down here you see this prompt, and at this prompt is called a command line. You could type commands such as ls for list the contents of a directory, or you could cd into a directory. So these are so-called command line tools or commands. So we want you to become familiar with how to program at what we call the command line. We also want you to become much better at debugging programs. So you were introduced to debugging, obviously in CS102, probably did a bit more in CS130, but in this course the programs become significantly larger, and it becomes significantly more difficult to find errors in your program. And therefore, we want you to learn different debugging techniques and to become comfortable with using them to find errors in your program. Also, so command line tools, so this is all part of becoming self-sufficient C++ programmers. We want you to learn command line tools. We want you to become better at debugging. And then we introduce some new concepts that you have not seen before in C++, concerning pointers, recursion, and memory allocation, which we'll get to those concepts in the second half of the course. So those are additional tools that you'll add to your C++ vocabulary or tool set that you did not learn in CS102. So those are all part of becoming self-sufficient C++ programmers. Then the third thing we're going to introduce you to is something called algorithm analysis. And that is being able to look at an algorithm or a computer program and be able to determine what is the running time. How long does it take to run given a certain set of input? It should be clear, let's go back to the telephone book, that finding my name in the New York telephone directory, which has probably 20 million entries, is going to take longer than finding my name in the Knoxville directory, which might have about 500,000 entries. So we want to be able to determine the running times of algorithms. So running time is going to be our predominant concern. And we're going to definitely be looking at it as a function of the size of the input, because generally the size of the input determines how long it takes an algorithm to run. And the reason that algorithm analysis is important, let's go back to those insert, find, delete operations we want to perform on a data structure. In order to compare different data structures and be able to determine which ones perhaps are more efficient, which ones are less efficient, we need to know how fast their insert, find, and delete operations are executing. And the way that we determine how fast those operations are executing are using algorithm analysis. So that's why you need to learn algorithm analysis. And then I guess I already alluded to this in bullet point 1. We want you to become familiar with using command line tools. And you may, definitely at the beginning, most of you are going to think, why are we torturing you with learning command line tools when it seems so much easier to use a visual editor like CodeLight or like Eclipse or NetBeans or some other editor that you might be familiar with. And the reason is that it comes down to something called recognition, whoops, if I could spell correctly, recognition memory versus recall memory. And I'm going to write down two others, novice versus expert. So novice users of technology generally rely on something called recognition memory, which is the ability to recognize a command given a list of commands. So for example, if I want you to delete something in a text editor, which unfortunately I don't have, well, here we go. So given this list of commands, which one do you think is going to delete something from a text editor?
Delete.
Pardon? Delete, but it's not up there. It's actually grayed out. So there's another one that could also work. Cut. So given that list of commands, you could work out that cut is the one that is available. Delete is grayed out. I know it's a little hard to see from the back. You could also probably figure out that if you delete were active, you'd probably choose delete over cut. So that makes use of recognition memory, the ability to recognize a command when presented with it. Versus recall memory. Recall memory comes from memorizing things. So now I might just ask you, what is the command for deleting something in a text editor? And now from recall, you'd have to tell me it is the cut command. You might also know that it is you might know the shortcut for it, the keyboard shortcut for it. Okay? So copy is generally some kind of Control-C. I don't use cut too often. I think it's X. Yep. So you would use on the Macintosh the flower X. So if you memorize those keyboard shortcuts, you would be using what is called recall memory. Experts use recall memory. Novices and intermediate users use recognition memory. The reason you probably like visual editors is you really haven't memorized the commands very well, and it's easy to mouse through the menus and find the command you want because you'll recognize it. So you're using recognition memory. But that's actually not very efficient to go mousing through commands. When you do that, actually every time you have to move your gaze up to a menu and away from whatever it is you're editing, you do what is called a contextual shift in your brain. And it takes, on average, about 15 seconds for you to reacquire the context when you go back to whatever it is you're editing. So every time you have to go and scan a menu in order to find a command, not only are you wasting that time scanning the menus, but you also are going to have to spend about 15 seconds reacquiring the context when you come back to whatever it was you were editing. So you're probably going to lose a good half minute every time you don't remember what a command is. You can well imagine that over time, these half-minute losses add up to a fairly big time drain. It's much better if you can memorize commands and reproduce them from memory without having to go to menus and also leave the current spot on the display where you were working. That's what experts do. They have memorized commands, and the operating system that you're using this semester, called Unix, is an expert's operating system, whereas Windows and Macintosh are meant more for novice and intermediate users. That's not to say expert users don't also use these two operating systems, but Unix in particular was designed for expert users because it relies on these command line tools, which you must memorize the commands. You must memorize the fact that to change to a new directory, you no longer can double click on a folder. Instead, what you're going to have to do is type CD for change directory. You're also going to have to become comfortable with the fact that Unix did not always choose very mnemonic names for certain commands. So to list the contents of a directory, you might prefer something like dir or listdir. But that is not the name of the command the Unix developers chose. They chose a fairly un-mnemonic name called ls, which lists the contents of a directory. You're just going to have to memorize that. But once you've memorized it, you can be much quicker in navigating through directories on your computer. For example, to get to my CS140 Fall 18 notes or lectures, I can just type, well, if that was the right thing, it's not, but I could have just typed a series of directories. The reason it's not is because it's actually in CS140-Lec. At any rate, I can get to whatever directory I want by typing a series of directories, or in essence folders, instead of having to click through a series of folders, which would take much more time. So the reason we want you to become familiar with using command line tools is because it will increase your productivity as a programmer. You'll no longer be wasting these 30-second chunks of time trying to discover the command you want to use. Now, conversely, in the first few weeks of this course, you will waste a lot of time, energy, and patience trying to recall these commands. So it might take you 2 minutes to search the internet to remember that ls is actually the command for listing the contents of a directory. So for the first few weeks, you'll probably think that you're being tortured or that this is actually a way to suck down your productivity rather than increase it. But as you memorize these commands and commit them to memory, eventually they'll become like muscle memory. You won't even think about them. You'll just basically type them out and they'll be there. And then your productivity, you'll see, will start to increase rapidly. I would encourage you to create lists of these commands and just have them available when you are programming initially. So just on a sheet of paper have them, because that way at least you can just scan down that list. So questions about this? I know I've spent some time motivating the course and talking about the goals of the course, but I really want you to understand why you're taking this course and kind of how it fits in the scheme of things. Yes?
I just want write down a list of all the commands. Where do I find a list of all the commands?
So it's basically as you start using these commands, you're going to kind of say, okay, I use CD a lot to CD, so you'll add that to your list. I use LS a lot, so I should add that. So it's more like keep that list in a pen handy or a pencil handy because you'll find out which you use. And it's actually different for different people, it turns out. Okay, other questions? Okay, so let's go over logistics next. The website for the course is pretty important. So you're going to find a lot of things on this course. I know it's a little hard, so I'll put it up here. It's web.eecs.utk.edu CS140. So that gives you the web page where you can find things, course information. So course information where you'll find things like office hours, our office locations, the names of the TAs, the grading scheme for the course, lecture notes, we'll go over that, but assigned readings for the class. Piazza is the discussion board for the class, and you'll need to go there to sign up for it. That's where all announcements for the class will be. It's better than the discussion board for Canvas, in my opinion. There's a link for the labs and the in-lab assignments, so each week you'll know what's going on in lab and also what's assigned. Don't worry so much just yet about the top coder problems. We'll get to that in a couple weeks. Sometimes students want practice problems, so I have a couple sites where they can find practice problems. Oftentimes you want a quick place to find where the exams are or what times they are. The exams are always in here or in the labs, but this link will give you actually access to previous exams, not just yet, but closer to the time of the first exams and when they are being held. And finally, the TA contact information. And actually, we have a Google map, not map calendar down here, telling you when are the times for the TAs. And actually, if you just click, it will tell you what the times for the TAs are. And in general, we're going to try to have 2 TAs, if possible, at many of these office hours. So even though you just see the name of one, that's the person who should always be there. We're going to endeavor to have 2 TAs at the office hours. That won't always happen because of their schedules, but that's what we'll endeavor to do. So that is where you find information. Then Canvas we do use because Canvas is where you will be submitting your lab assignments, and it's also where the grade book is kept. So submit labs and your grade book. The grade book is there as well. Also, this is where you should find your Zianti textbook for the course. So you should have a link in Canvas to your Zianti textbook. I'm actually going to ask if people have been able to get access to the textbook. Need nodding or vigorous shaking? Yes. So right, so actually let's just go take a quick look. So it's working for me, so although I use a different site, so just a moment. So you should see under lab assignments, actually, there should be a link called Zybooks. And unfortunately, since I'm the instructor, it probably takes me to a different screen than it takes to you. And for me, it comes up with this CS140, data structures and algorithms. It sounds like for you it came up with Spring. Okay, you probably want to try to go through Canvas because there should be a link to it in Canvas for you. Yes.
So that link right
Mhm.
there, that specific one, does
Mhm.
not work. It gives you a message, and I see a lot of people's computers. Message: an instructor has not yet configured this link to point to a Zybook section or assignment. But if you go through modules and you click on a lecture, you can get to the.
Okay, well, let me get in touch then with the. Okay, so if we go to modules and you go to like lecture 1, now you can get into it?
Yes.
Interesting. Okay, well, I will. Okay, I will talk to the appropriate individuals this afternoon and we'll figure out how to get that link configured so you can go directly through the link. Because don't want you to have to always go through the modules in order to get access to stuff. Okay, so I will post an announcement on Piazza once we have that link working and configured. Okay, so we will make that happen. Okay, so that's where you can, so again, Canvas is where you find the lab assignments. This is just the submission links. This is not where you will find the pros for the lab assignments. The pros will be on the web page. So this is just where you will do your submissions. I'll talk about the pre-class participatory activities and the post-class participatory activities in a moment. Okay, so back to the main website. So the course information has the information about where I reside. So Mingal 312 has information about my office hours, which are going to be Tuesday from 2 to 3, Thursday from 3:30 to 4:30. Those times don't fit you. You need to make an appointment, that's fine. Just send me some email or see me after class. As I said, the textbook, I don't think you're going, so this is what they said to do, but this was before we were going through the university's book system. So these instructions, I think, are out of date. They might or might not work. Well, they certainly don't work because I see spring 2018 there rather than fall 2018. So that might work, but the university was supposed to make this easier than that. So that's why I hadn't actually updated those instructions. Okay. Then the teaching philosophy, you can read that, but basically it is better if you come to class having already read the material in the textbook. That's difficult in general to make you do. However, the ebook that you're using for this course makes it very easy because it has what are called participation activities. So the book, let's look at the readings for today, which obviously I don't expect you to have already done. So comments and white spaces. So you start reading, blah, 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 some figures. And then here we go, participation activities. So what the book does is it has these short sections followed by these participation activities that quiz you over the material that you just read. And the reason for doing that is that practice, practice, practice makes you perfect. So when you have to rehearse material shortly after you've seen it, you tend to get better at it. So they have these participation activities laced throughout the book that are interactive and that force you to answer, and they also record it for me so that I can see whether you have done it or not. So before class, I assign readings and expect you to have done these participation activities, and we can download spreadsheets from the publisher, Zianti, which tells us whether you've actually done them or not. And as you'll see, when we get to the grading scheme, part of your grade is did you do the participatory activities. So oftentimes they're just some kind of multiple choice or true false. Sometimes they are actually making you look at a figure. So what I like about Zyanti is they have these interactive figures which actually take you through the actually, unfortunately, I don't have a lot of room here, but they kind of animate things. They have little captions at the bottom. So they're like animated figures that step you through a figure with multiple captions. So the participation activity may simply be, did you go through the animation and watch the animation? Okay, and sometimes, I don't think it's going to be in this section, no, but sometimes the participation activities ask you to write a few lines of code. Yes?
So the due dates that are on those links
Are not current.
okay.
Only for the first 2 assignments are they current.
Okay, so are those the days on the first 2 assignments where that's what we should have read it by? Like, is that the day we're
Yes. So, for example, today's reading assignment is actually not due until next Tuesday because obviously I don't expect you to have read stuff for today. And then, so you have a 2 for today. You have to read both today's stuff and you have to read the stuff for Tuesday. So, those 2, I'll expect you to have all the participation activities done by 11 o'clock Tuesday morning. Okay, and then I'll get over the weekend, and I'm going to get more and more of the dates updated. There's just a whole ton of dates that have to be updated. So by the time you get to them, they will be up to date. Okay, same thing with the labs. Only the first 3 labs have the right due dates right now. Yes.
When you're doing these quizzes, are you allowed multiple attempts, and do they show your grade like when you're done, like what you got right?
So yes. So if I'm not sure if they allow you multiple attempts or not, but they definitely tell you whether you are right or wrong. So I'm just going to randomly select something. Okay, incorrect, and it says why it's incorrect or correct. Oftentimes the comment is the same whether it's correct or incorrect. But it'll tell you immediately, it gives you immediate feedback as to whether it's correct or incorrect. And I'm guessing you can actually change the answer. Okay, so.
Do you get a history of that? Like, this guy, got everything wrong.
No, all I see is I get a spreadsheet and it just says what % of the activities. I always think it's what you did rather than, yes, did you complete it or not, as opposed to, I think, whether you got it right or not, because I'm pretty sure that you can change the answer to be right if you got it wrong. Okay. Yep. So sometimes I've noticed the book even seems to use the participation activities to introduce new material, which can get a little frustrating, so don't worry about it. Okay, I'm pretty sure that it's just, did you participate? Okay, so if sometimes this isn't so much true in this book, but in some of their other books, it seems like they sometimes introduce new material in the participation activities. So don't start grinding your teeth and thinking this is unfair. This is just their way of doing it, and I'm pretty sure they're just saying, did you complete the activities? Okay? What I like about Zybooks is, and they say, look, we know you don't like to do a lot of reading, so we make it short, we make it punchy, and we don't have a lot of material in any section. Okay? So it's also the participation activities break things up. So if you're getting bored reading, very quickly there'll be a participation activity to break things up. So I really like Zybooks for all those reasons, and I've gotten good feedback about them. They also have challenge activities, which sometimes I will have you do in class. The challenge activities are a little beefier. Typically, you're writing a little bit of a program. And they're, again, you're actually being told, though, they run against some test cases. They tell you whether they're right or wrong. They give you a chance to correct it. So, again, basically, it's what's reported is your final result, not the intermediate result. And sometimes I'll have you do the challenge activities as post-class activities. So if we go to the lecture notes, you'll see that we have before class participation activities where I assign stuff. I have during and after class challenge activities. That's things I may do either during class or I may have you do shortly after class or maybe even in the lab. And those are to keep you, again, rehearsing material. And not too long, just to make sure you're rehearsing material because otherwise you may delay doing any studying until the midterm, which is too late. Okay, so this is kind of designed to keep you always rehearsing the material along the way. Early in the course, you cover a fair amount of material in the book, and if you don't do all the participation activities, that's okay. I mean, you won't get full credit for them, but I can see where it can get a bit tough at times. Now, that said, the book claims that most chapters between the reading and doing the participation activities shouldn't take you much more than 1 to 2 hours. And I know that may seem a lot of time to put into reading a textbook, but believe me, it does pay off in terms of being really conversant with the material. And then sometimes I try to break it up, like with the strings in a couple lectures, you're reading a whole chapter, so I divided it up into some activities before class and some activities that we'll probably do during class and perhaps a little bit after class. At any rate, again, the whole idea is to keep you rehearsing this material. You can see that for going back, these are the lecture notes. So for every date, there are some online notes that talk about in more detail, usually examples. So the book tends to be a little light on the examples. So the online notes have beefier examples. So here's the notes from today. And the person who did them is Dr. Jim Plank. He will be your CS302 instructor. And generally, I follow his notes because he expects when you come into 302, he has a pretty particular way of doing things. He likes it if there is some continuity. And he and I are good friends, so I'm more than happy to use his notes because they're outstanding in my opinion. So his notes give kind of in-depth examples, whereas the readings give you more of the introductory and the nuts and bolts. Okay, so the textbook is more, here's the nuts and bolts. The online notes are, okay, here's some kind of beefy examples of how to do stuff. Plus, sometimes there's some stuff that's not in the textbook. Then I tend to, when I remember, which is most of the time, like today, I'm taping this lecture. After class, I will upload it to YouTube and create a link to it. And that is by clicking through on the lecture link, you can review the lecture. Okay, so if you miss a class, don't worry about it. No need to send me email. Just review the lecture link. Or you missed something in class, want to go back and review it, check out the lecture link. Okay, you're studying for the midterm, want to check something out, check the lecture link. Okay, so it's nice, and actually probably going to work with a group down in Florida who is apparently using some AI to try to actually caption the lectures and also create search terms for them. So we'll see how that works. Once we actually have it up and running, I'll post some information on how to do it. For the time being, just clicking through on the lectures. Those are usually up by the evening of the lecture. So I have lunch after this, I have another lecture, then I have meetings. So usually the lecture is not posted until sometime in the evening. Okay. When you see the lecture link, it's usually from the previous semester. So actually you can see what I talked about in the spring until this evening. Okay, so that is the stuff there. Then, as I said, make sure you sign up for Piazza. That is where the announcements for the class will be, not on Canvas. So I expect you to sign in. Also, Piazza is where I want you to submit your questions. Don't email me or the TAs. Please submit your questions to Piazza. That will get faster responses because either me or the TAs can respond to your question, and 5 eyes looking at it are much more likely to respond quickly than one set of eyes. Plus, oftentimes someone else has that same question, which means that rather than getting 5 emails with the same variation of the question, there's just one question up on Piazza, and you see a consistent answer. I don't give one answer, the TAs give another answer instead. You see a unified answer up on Piazza. So please generally post your questions to Piazza. It does have a way of either posting it to the class or posting it privately just to the instructors. When you are uploading a coding question about your code, please make it only available to the instructors so other students don't copy your code and create plagiarism problems. Also, when you're asking a question about code, please upload your entire code, not just the few lines you think are wrong, because oftentimes it's not those few lines that are wrong. It is something else in your program, and we'll end up saying, could you please upload your entire program? So please just do that the first time. Okay, then the labs and in-lab assignments. The big thing is the lab assignment table. So there's normally a new lab. Sometimes the labs are 2 weeks. When they are, you normally have intermediate deadlines. We won't get to one of those until lab 3. Then sometimes there's an in-lab activity, like yesterday it was learning Unix. For the next couple weeks that will be debugging. Sometimes it may be a challenge activity from the book. Next week, the in-class lab activity is debugging, and then you'll spend time with lab 0.5, which is kind of the warm-up lab, which you'll try to get done in the lab, and if not, then you will finish by September 1st. So normally, starting about week number 3, you'll have also something called a top coder problem, which is a website that has kind of challenging but short coding problems, and we pick one each week that is related to the material from the course, and what we're trying to do is just get you to think creatively, to do problem solving. So both in CS102 and quite frankly in these labs, a lot of the solution is well structured for you. We kind of say this is the solution, follow steps 1, 2, 3. But to become a good programmer, you have to also learn how to solve problems on your own. And that's what the top coder problems are trying to do. They're like puzzles, really. They're not long to solve. Once you figure out how to solve them, they normally only require a few lines of code. But the big thing is figuring out how do you solve it. Okay, so we're hoping that by doing these problems, they make you better at problem solving, which is an important thing to learn in addition to learning how to code. Okay, so normally there'll be, in labs, the first hour will be some kind of in-lab activity. The second hour will be a top coder problem. And the third hour will be the lab for the given week. Either some introduction to it or you'll start working on it. Lab attendance is mandatory. Okay, you will be graded on it. There will be some participation grade for the labs. Okay, and we have a way of checking whether you were there, which you will learn about in the labs. Okay, the labs are graded, actually, let's go back. The labs are graded using a script, which you will learn about next week. So, in fact, all the test cases used to grade your lab are available to you in advance. You know when you submit your lab what 80% of your lab grade will be because the script will have tested it against either 100 or 200 test cases, and you'll know how many of those test cases your lab passes. So 80% of your grade is actually correctness. So let's actually go to that. 80% is correctness, 20% is commenting and programming style. So how well do you comment? How well do you organize your program? So organizing a program well is like writing a good paper. The logic is clear and easy to follow, as opposed to convoluted and not easy to follow. So how easily read your program is part of that program style. Commenting, do you have comments in front of each of your functions saying what that function does? If there's a complicated piece of code in the middle of the function, is there a short comment describing what that piece of code does? And do you use meaningful variable names? I'm a big one for using meaningful variable names. Unfortunately, Dr. Plank doesn't. The textbook in general doesn't. But for people reading your code, it is very helpful to use meaningful variable names, and you will be graded on them. Also, if you're wanting more information, I have a section called Commenting and Programming Style, where you can look at comments from me, Dr. Plank, and a third person about commenting. Okay, to get lab help, you can visit me during office hours, or you can make an appointment. You can visit the TAs, not in the programming clinic. Need to fix that. MinCal 217 is where the TAs will be, so get that fixed. That's so that you aren't clashing with the CS102 students. So MinCal 217 is where the TAs hold their office hours. And it's not the TA webpage. I'll get that fixed. We have a calendar this time telling you when the TA office hours are. Or you can post a question to Piazza. This is certainly something you can do when you're at home, on the weekends, in the evening. Now, having said that, both me and the TAs have other things to do, so when you post in the evening or on the weekends, don't expect a very fast response. And perhaps another student can also help you out. So please, if you see something on Piazza, you think you know the answer to the question, help out your fellow student. Now, of course, if you posted code, only the instructors can see it. We'll do our best to get to you, but especially on weekends, you can't expect a very fast response. So those are the 3 ways to get help. Let's see, lab attendance. Mandatory late labs. You can submit labs up to 3 days late. You'll have 10 points deducted for each lab. And I make the labs due at 6 a.m. So you need to be careful about that. So many of you are night owls and like to submit or work on your labs late at night. So when you see something like Lab 0 is due at 6 a.m. on Monday, what it really means is it's due Sunday evening. Because 6 a.m. Monday is Monday morning at 6 a.m. Okay? So whenever you see the day, it's really the night before that it's due. Okay? Wednesday, September 5th is really Tuesday night, September 4th. But if you're a night owl, feel free to work on it till 6 a.m. Now, I will tell you that I always see Piazza posts at 2 a.m. with no response. Pretty confident that if you're working on it at 1 a.m. or 2 a.m., you are not going to get a response. Okay, you're probably on your own. But normally the next morning, I will respond to you. You can certainly hand it in late if you haven't finished it. But this works out well. People tend to be pretty happy with the 6 a.m. due date. Okay, and then I actually don't drop a lab, but the labs in total are worth 1,200 points, but your lab grade is out of 1,100. So effectively, you don't have to do one of the labs. A better way to think of it is, hey, this is a way to get extra credit, because if you did every lab and got 1,200 points, your lab grade would be something like 109, and that will count as bonus. So in fact, whenever I hear, can I do something for extra credit? Yeah, you could do all the labs. Okay? And if you do that, then it is a way of getting extra credit. Okay? So, and there's the tentative values of the labs as well. Questions about the labs? Okay, so I think that pretty much covers it. Plagiarism, they're very important. Don't work with other people on your code. If we see two programs that are the same, we have to assume that you copied off of each other. We can try to disentangle it in will, but generally it goes like this. Student A, I never knew student B. Student B, I don't know student A. I have no idea how these two are identical. Okay? In which case, both of you get zeros or get Fs or something. So the range of penalties goes from a 0 on the lab to an F in the course, and referral to student judicial affairs. So please don't do it. Don't also plagiarize from the web, okay? That's not cool either. You can take code snippets that I provide you or the TA provides you. Those are fine. So if you see code snippets in the online notes or in Zianti, yeah, those are fine to use or modify. But if you see someone else's code, don't copy it. That's plagiarism, okay? So it's fine also to talk in general terms with each other about your strategy for solving a problem. I mean, that's natural. You'll get stuck. You want someone else to look at it or help you. Fine, but when it comes to coding, sit down and do it separately, okay? Because you two can come up with the same approach, but if you sit down and code it separately, guaranteed your programs will look different, okay? So that's it on the plagiarism stuff. So lecture notes, blah, blah, blah. Exams, as I said, closer to the time of the midterms, I come up with sample exams. Don't have those up yet, so don't worry about that. TA contact information, as I said, office hours will be in MinGal 217. Here's the calendar, so on any given day, just click. You'll see what the office hours are for that person. Okay, so we have about 15 minutes. Today's not meant to really plunge you into things, but I do want to show you a couple things before letting you go. You already started to see a few things yesterday, but you're going to be compiling. I guess what I want to show you in the last 15 minutes is a short program and how you compile it on the command line. Did the TAs go through this with you yesterday or not? I didn't think so. Okay, so a short introduction to how you compile a program and get it to run when you're working with the command line. So the first thing is you will need to get a so-called terminal window, which is different on each of the three operating systems. So on the Mac, it's pretty easy. There is a utility. If you go to Applications, you go down to Utilities, there is a program called Terminal that will give you a terminal window. Very nice, because the Mac is actually based on the Linux operating system. Linux is actually just is one of the variations of Unix. So you'll often hear us say Unix or Linux. They're the same, they're just different dialects. Okay? So the Mac is nice. It's based off of Unix, so when you get a command line or when you get a terminal window, you already have access to the command line. If you have a Windows box, it's a little more complicated. You actually have to download something, and if you go to today's lecture notes, then it says where you are and where you are going, and there's a little blurb near the top which tells you what you can do on Windows to get your own terminal window. So you should follow those instructions. If you're having difficulty, go see one of the TAs during office hours. I told the TAs to start holding their office hours this week because I expect there to be these issues with how do I download the software and get it to run. Yes?
Will there be any problems using MOBA external? Will that be everything we need to do as far as getting it?
As long as you can get it to run,
Okay.
it's good. Okay, I don't care how you do it. Just if it works on the command line, you're good. Okay, we really don't want you, however, using an integrated development environment. We want you to get familiar with using a terminal window in this course. Question? No. Other questions? Nope. Okay. So I'm going to assume at this point you've gotten a terminal window and you are able to get to your directory. So in this case, I want to get to my play directory, and I'm going to use VI. I know many of you will use Vim. That's fine. So you will be creating programs. First of all, there we go. You typically name your programs, the name of the program, and then .cpp. So in Unix, you have extensions. It's not just Unix, Windows, Mac. They all have extensions. Common extensions for C++ programs are .cpp because CPP stands for C++. Okay, so we VI, and I've already got the program written. So if you forget with VI, it's what's called a moded editor. So if you want to insert something, you start with the I button, and that will put you in insert mode. And I could now insert other stuff, which I don't need to do because I already started it. And does anyone remember how I get out of insert mode? Escape. Okay, so at any rate, I have my program already written. It's hello world. How do I write it out? Colon. W, and that writes it. If I also want to quit at the same time, WQ will write and quit. Change the commands. So here is the compilation. G++ is the program that compiles your file. Okay? So on the Mac, you may actually have to download something called Xcode in order to get the compilation tools. So just warning you, you may have to go through that, and if we don't have instructions for that, I will do it. Many of you should already have Xcode on your Macs from CS102 or 130, so it shouldn't be an issue. Okay, so you type G++ and nothing happens, or nothing seems to happen. But in fact, it creates a file called a.out. Why is a.out? I don't know, but way back when the first C compiler was written, C++ is based on a language called C. They named their so-called executable files a.out. So in order to execute it, the dot, you see the dot backslash here, that says I'm looking for the file in the current directory. Okay, so the dot / in Unix says we're looking for the file in the current directory. And the name of the file is a.out. And when I execute it by hitting the return button, I get the expected hello world. Okay? Now, can anyone think of a problem with it always naming the file a.out? Yes. You're going to overwrite it every time you do it. So if I have another program, byworld, that's going to also get compiled into a.out, thus destroying my so-called executable for a.out. So we call a program or a file that can be executed an executable. Okay? So if I don't have byworld, so it won't work. But what I normally want to do is I want to name my executable, and I don't want it actually named a.out because it will get overwritten. So the -O, this is called a flag. This is called the -O flag. So you can give commands, this is called a flag. You can give commands in Unix additional information via what are called flags. And flags have a dash in front of them. And they're not always single letters, but often they are. So this says, name the output file hello world. So after a flag, there is often an argument for that flag. In this case, that argument is hello world. So it says, I want to name the executable hello world, and then at the very end, hello world.cpp is the file that I am compiling. So now, what is my problem? That looks pretty good. Linker command failed. I'll have to take a second. Let me get rid of that. Pretty sure I'm not messing that up. Let's do something. Let's try logging in to the Hydra machine just a moment. Ah, is that an issue? No. Okay. Ah, but this is a good time for this. Okay. So sometimes you have syntax errors. So in this case, it produces a whole bunch of messages saying that, starting with this one, hello world, line 1, error include does not name a type. What? Include does not name a type, but it does name a type. I want IOStream. What's really the problem? I missed the pound sign. So rule number 1 is that the compiler doesn't often give you very informative error messages. Okay? So you often have to decipher them. Rule number 2, don't go solving your second problem. So it says your second problem is cout was not declared in the scope. Don't debug your second problem first. Debug your first problem first, and often the remaining error messages will go away. The reason you got this error message for cout was because IOStream was not included, and therefore cout was not recognized. So the second error was caused by the first error. So generally when you have compilation errors, you fix the first error and then you recompile. The reason being, often a lot of the remaining error messages are caused by the first error message. So we recompile, voila, it worked. I have no idea why my Macintosh is acting up right now. Okay, so I'm going to have to check to see what the heck is its problem. Okay, because that is the correct command running on the Hydras. Now, notice what I did here. That may look a little funny. Okay, Unix has a history mechanism. And the exclamation mark says, find the most recent command that started with G and execute it. It's cute. Saves you a lot of typing. If you type the actual command history, you will see a list of the last number of commands that you have done. So there's a whole bunch of things you can do with the history. You just saw one of them, which is if I do exclamation mark G, it will execute the last command that started with G. If I do M, which one do you think it will execute? Make dir play, because the most recent one involving an M was make dir play. Or I could enter the actual command, if I could get it right. So that would also execute that command again. I'm not, because I don't want to redo it, but let's say 89, it redoes the command. Or using the arrow keys, I can scroll back through the history with my arrows. Up and down arrows will get me through the history. All kinds of neat ways for you to not have to type stuff out again and again. Again, history gives you the list. The exclamation mark is what gets you the name of it. or starts saying, I want the history. And then if there are, let's say that the command started with GC rather than G++, now I'll get the first command that started with GC. Questions? Yes.
Going back just a little bit, when you renamed your executable hello world,
Mm-hmm.
is the a.out still created when you do that?
No, the a.out is no longer created. So now instead of creating a file called a.out, it is creating a file called hello world. So it only creates the a.out file if you fail to use the -o, which you should never basically compile without the -o option. Okay? Yes?
Is hello world still in .out?
It's still there. Actually, it does not remove the a.out file. So if I went back right now to my other one, it's still there. Okay. You'd have to remove it.
Is hello world end in .out still?
Is, pardon? Hello world.
Is hello world, like, what's the file extension on that?
There is no file extension. So for an executable, there is no file extension. It's just the name of the, typically the name of the executable will be just a shortened version without the .cpp. Okay? Yes? In Windows.exe will work fine. Yes. Right. So in Windows.exe will work fine. On the Mac and on Unix, it does not work fine. Still got 2 minutes, y'all. So, okay. So one more thing before we leave today. So actually a couple things. First of all, you can get sometimes what Dr. Planck refers to as looking like vomit on the screen. So I just changed the cout, so instead of being less than, it's greater than, which is the wrong operator to use with cout. If I compile this thing, I get an enormous quantity of error messages, all just from using the wrong operator. You can see that at the very beginning, it at least puts an arrow under the greater than, and then it just has a lot of stuff that, believe me, you don't want to look at, okay, and is not particularly useful. So you just should, again, be forewarned that a whole lot of error messages can come from one very innocent mistake, which in this case was doing the greater than rather than the less than. One final thing, and then you can go. There is a second kind of compile error, which you won't see for a little while, but we will still show it to you very quickly. Okay, so here is a function, foo, that I'm calling, but in fact I never provided a function definition for foo. I declared it as a prototype, but I never provided a function definition for foo, but I tried to call it. And I get a in function main undefined reference to foo. That's not exactly a compile error. It's actually called a linker error. Okay, so you can also get so-called linker errors, which is that the symbol is defined, but it was not found. So probably on Tuesday, I'll show you what that looks like on the Mac, because on the Mac, it's a little more confusing than this. Okay, so remember, you have participation activities that you need to finish by Tuesday. You will find the links on Canvas for these participation activities. So go to Canvas, find the links, click through on the links, and then do the participation activities. And I will try to get that Zianti link fixed so that you all can use it.